All right, let's talk about Hamilton paths and Hamilton circuits. So in 14.2, we talked about Euler paths and Euler circuits. So if you take the definition of those and you replace edges with vertices, then you get the definitions for Hamilton paths and Hamilton circuits. Okay, so that's what we're basically going to do and explore what happens with those. So here's a couple of definitions. Like I said, I basically took the definitions for Euler paths and Euler circuits, replaced the word path with vertex or vertices, and we get these. So in 14.2, we also talked about Euler's theorem, which allowed us to find Euler paths and Euler circuits. Unfortunately, there is no Hamilton theorem which will help us do that. So we're going to have to basically do this by trial and error. There's some other methods we're going to discuss, but no, there's nothing that will do it for every single case. We just have to make some observations. All right, so let's look at some examples. Okay, so we're going to find Hamilton paths and Hamilton circuits. Hamilton path is a path that passes through each vertex of a graph exactly once. And a Hamilton circuit is the same thing. It passes through each vertex only once, and then of course comes back to itself. All right. So I've got a few of these. We're going to start with this one. It says to find a Hamilton path given this graph. Okay, there's several. In fact, we might do a couple of these. All right, so we're going to find the Hamilton path. We need to go basically through every single vertex. I'm going to start at C first. So I'll start here at C. That's my starting point. Since I'm only finding a path, I don't have to come back to C. In fact, I don't think we could. So here we go. I'm going to start with C. From C, I don't really have any choice. I have to go to B. B. At this point, I could go from I could go to D or I could go to A. But if I want to hit these other ones, I got to go to A next. Then I can go to D, and then E and F. Okay, that's one option. We could start at the other end. We could start with F, so maybe we'll do that. I'll start with F. That's one. Another is F, E. Got to go to D. Well, if I were to go to B, I could go to these two, but I want to end up at C. I better go to A next. And B, C. I basically just did the inverse. All right, so that's a Hamilton path. Now we can look at a Hamilton circuit. We got this graph now. I am going to start with A. In the homework, they're going to tell you generally what to start with, or you can deduce it from the multiple choice options. So let's start with A. I have to come back to A if it's a circuit. All right, I'm going to trace this one, I think. Again, there are multiple, but I'll go to B next. Okay, from B, I could go to E or I could go to D. I'm I'm going to just be simple here. I'm going to go to E next. Okay, so let's do that. I'm going to go to D. Now, at this point, I could go, I got to end up at A. I got to end up at A. So I better go, I better hit, I think, B. Nope, I got to go to C. It's not about the edge, it's about these vertices. So I got to think that way. So we just did A, B, E, D. I'm going to go to C. And then I want to end up, since it's a circuit, I'm going to go back to A. So that is a Hamilton circuit. So in this example, or since the notes for 14.3 are going to have lots of examples, we probably will have 2 videos for the notes and then probably 1 video for the homework, because many of the problems, similar problems, will be done in the notes. Okay, so here's another one. This looks like a bit of a dog bone. The way this one's worded is to say, it says, find the Hamilton path, a Hamilton path, a Hamilton circuit, if possible. Of course, if it's a circuit, it comes back to its starting point. If it's a path, it does not have to. So let's do the path first. I'm going to do Hamilton path, just so we know the difference. Hamilton path, I'm going to start with, I don't know, I'm going to start on this side of the dog bone. Call that, that's U. This should be an uppercase, but sometimes my U's and V's look the same. So this is a U, should be uppercase. I'm going to go to that V next. And I'm doing that because if I went to the W, then I'd have to go back to the W after the V. So let's go to V, W. Now we can cross this bridge. And I could go either Y to Z or Z to Y. It doesn't matter. So, Y to Z. All right. Now that was the Hamilton path. Can I find a Hamilton circuit? Well, the problem here is this bridge. Once I cross that, I can't come back to it. I would need, for the circuit, I would need to end up where we started, but I'm not going to be able to do that. So there is no Hamilton circuit on that one, just the Hamilton path. Okay, and I think I want to do one more example, I believe. We'll do this one right here. Now, I haven't drawn the graph yet because I want to tell you how I'm drawing it so that it's not too confusing. Each of these vertices up top, ABC, will go to each vertices down on the bottom. So A goes to D. E. I'm going to draw it this way. You'll see it. There's going to be some stuff that overlaps. And I want to make it easier to see. Now, B will go to each of those. B will go to D, E, F, G, H. I'm not going to connect A to B to C or D to E to F to any of that. So the ones on top go to each one on the bottom. Okay, that's kind of messy, but hopefully you see it. And then the C will do the same. Okay. I'm going to do this for that one. This B, I'm just moving it just so it doesn't look like it's the same line. All right, I think we got everything. A matched to all of them, B matched to all, C matched to all. And then likewise, all the ones on the bottom will go to the ones on top. So the question here says, find a Hamilton path and a Hamilton circuit for the graph if it's possible. So let's go to A. I'm going to start with A, and I'm going to try to do this. I'm going to start here. I'm going to go from A to D. Now, once I'm at D, I can only go to B or C. Okay, so I'm going to go to C just to change it up. Now, once I get to C, I can either go to E, F, G, H. I'm going to go to now at H, I can either go to A or B. I'll go to B. So that's this kind of curvy one because it kind of looked like it was intersecting. I changed it up a little bit. Now from B, I can either go to D, but if I go to D, I'm done, right? Because I've already gone, use these. I don't want to do that yet. I could go to E or F. Let's go to F. From F, I can go to A or C. Let's go to C. Now from C, I have to go, well, I could go to E or G. Let's go to G. Now from G, I could go, looks like I have to go to A or B. Now from B, I could go to E. That is that it? I've already gone to H, I've already gone to G, I've already gone to F, I have to go to E. I guess I could go to D. And from E, I have to go to A or C. I've already gone to B. A. From A, I could go to, I'm at a problem. I can't go to D. I can't go to E. I could go G or H. If I go to F, I'm stuck. Guess I could go to H, but look, if I go to H, I'm stuck. I don't want to do that. If I go to G, I'm stuck. I'm kind of stuck regardless. So I know it may be hard to see with the highlighter. You could try it on your own, do the same setup. You're going to end up not being able to finish that. So this is, we're going to have to leave that one right there. I'm going to stop the video there. So we couldn't find one there, unfortunately. No Hamilton paths or Hamilton circuits for that one. So we'll stop the video there. We're going to continue on the next video.